After doing some of our nutrient management basics, I'd like to talk about nutrient management and how this affects legume nodulation. So hopefully this presentation is a little bit more exciting than the last. Hopefully not as much information to cover, so we can kind of take our time with a few more things. So in this presentation, I'd like to do just a brief intro to what are legumes, talk about some of their advantages as a forage, how to establish them with a special note on how we manage nitrogen during establishment, and then how we manage nutrients in established stands, legumes versus grasses versus mixes. So starting off, legumes are plants that are able to fix nitrogen from the atmosphere, and they do this through an association with soil bacteria. And of course, legumes are used for grain, for human consumption, and then for our purposes, forage. So 78% of our atmosphere is nitrogen gas. So when you breathe in air, the majority of that gas that you breathe in is nitrogen. But of course, that's not really usable by plants. It's not usable by us either when it's in that form. But one of the beneficial things of biological infixation is that bacteria can take that out of the atmosphere and convert it to ammonia, which then makes it available for plant uptake. And so what happens is this association forms between these rhizobia bacteria and the roots of legumes. And so this is how these plants get their nitrogen. And the bacteria actually gets sugar and carbohydrates that are produced by the plant roots. So that is their source of energy. So this is a picture of a plant, and these are the nodules that you can see. So this is a well-nodulated plant. And through this process, plants can fix a pretty large amount of nitrogen. So in just a natural ecosystem, not an agricultural ecosystem, about 75 pounds per acre per year can be fixed. But of course, in our systems, we can fix much more, up to 300 pounds per acre per year. So this is a table from Alberta. And of course, these are in irrigated conditions. But in alfalfa, there is a crop that was able to fix 267 pounds of nitrogen per acre. And then, of course, it goes down the list, but sweet clover also did pretty well. So there is a lot of nitrogen that can be fixed from the atmosphere through this association. So I'm sure a lot of you have heard of alfalfa, bird's foot trefoil, maybe some of the sweet clovers, sainfoin. But one thing I do want to plug real quick is this Forage U-Pick tool. So if you are looking to create a mix for your field or even plant a pure stand, there's this tool online called the Forage U-Pick, and it's a tool for Western Canada, so Manitoba all the way to BC, and it, given your conditions and the area you live in BC, it can tell you some good legumes that you can plant and will survive in your area. So some other legumes you might not have heard of are Sicer milk vetch, Alsike clover, red clover, sweet clover, things like that. So moving on to advantages of legumes as forages. So obviously the biggest one is this biological infixation, mostly because it reduces our need for nitrogen fertilizer. So like in the last presentation, nitrogen is the element that is most needed by crops. And so with this association, we don't have to apply nearly as much. And through this association, the bacteria actually leave some nitrogen in the soil for some other plants, because nitrogen fixation is a somewhat leaky process, so they lose a little bit. And part of it is due to, some of the roots are dying, some of the older leaves are falling off the plant, and they're falling on the soil, and they're mineralizing. So in one study in Saskatchewan, there is an alfalfa brome grass mix that they found provided about 30 to 50 pounds of nitrogen per acre per year. So with some of the rates that are being applied in the interior, not much supplemental nitrogen may be needed. So good news for our mixes there. And then, of course, another advantage is the nutritive value that it gives to cattle, because legumes are typically higher in crude protein, digestible energy, calcium, and magnesium. So this is a table from Oregon State, and it has the stages of maturity in both grasses and legumes. And so these 4 different stages should correspond pretty closely to each other. So for example, pre-head corresponds to pre-bloom. So if you can follow the column that says CP here, that's crude protein, pretty much at every stage, the legume has higher crude protein than a grass. So obviously something that you'd want to make available to your cattle. So when you're establishing legumes, the first thing you want to think about is correcting the pH and then any soil nutrient deficiencies that you have. If you're not really able to correct pH, an option is to select an acid tolerant plant. So higher pHs above 5.8, alfalfa will do pretty well. But if it's below that, all-site clover, red clover, and bird's foot trefoil will also grow pretty well. So just because your pH is low doesn't mean you can't have legumes in your stand. Phosphorus is used by plants for root development, so something you might want to correct. I have seen some soil samples from the interior that are a little low on phosphorus. Potassium is used by plants for drought and disease tolerance, and then sulfur is used in nitrogen fixation. It's actually a part of the protein molecule that the plant is making. So like I talked about earlier, prior to seeding, when you're establishing, you want to correct those deficiencies, and the best way to do that is to incorporate those nutrients. And of course, the amount we incorporate is going to best be based on our soil test level. So in BC, our phosphorus recommendations are kind of split into 2 groups really for our purposes. In the first group, we have grasses, all-site clover, bird's foot trefoil, red clover, and then a grass legume mix that has less than 50% legumes. And then in our second group, we have alfalfa, white clover, sweet clover, and then a grass legume mix that has more than 50% legumes. So based on those and our soil test rating, we can determine how much we need to supplement to most effectively grow our crop. And like I promised, most of the soil tests I see from the interior usually are in that 15 to 29 range. So if I said your crop in the first crop group, somewhere between 54 and 89 pounds per acre, or if the crop's in the second group, also between 54 and 89 pounds. So hopefully not a ton, and hopefully not a huge cost to supplement those nutrients. Then for potassium requirements, there's really only 1 crop group. And so normally I see somewhere between 66 and 150, and lo and behold, that is again 54 to 89 pounds per acre. And so another thing to think about when you're establishing these crops is adding sulfur. Because like I said earlier, it's typically low in our soils, mostly because of the low organic matter content, but also where areas where air quality is improved, sulfur deficiency is becoming a problem. And so if you have a sulfur deficient crop, some of the symptoms are general yellowing, slow growth, and stunted plants. So of course that would probably prompt you to ask, aren't that the symptoms for everything? And so looking at this picture, if you were to show me these 2 leaves on the right, I would probably say, yeah, that could be almost anything. So visual symptoms, not the best thing to do or to go on. But sulfur in our area does likely need to be supplemented. Ammonium sulfate fertilizer is probably the most available fertilizer to add, but of course we don't want to add nitrogen for a lot of our legume crops because that's what they're fixing. So some other options are potassium sulfate and gypsum, which is actually calcium sulfate, which may or may not be available depending on where you live. And like you saw earlier, rates for sulfur range somewhere from 0 if you have sufficient in the soil, up to about 25 or 30 pounds per acre. And this is actually a table from one of our old BC agriculture documents. So it recommends for alfalfa to add an extra 10 kilograms per hectare, which is 9 pounds per acre, just to make sure that the alfalfa crop has enough. So when you're establishing legumes, one thing to think about or to make sure you do is you monitor soil nitrogen. And one of the reasons you're doing that is because excessive soil nitrogen can actually stop that inoculation process, where those bacteria in that plant root are becoming associated with each other. And that normally happens around 35 pounds of nitrogen per acre. However, there is some evidence that a little bit of soil nitrogen is helpful, basically to help those plants until the fixation process is able to start kicking in. And so from what I've read, around 10 to 15 pounds of nitrogen per acre is generally the ideal amount. But one thing to note is this fixation process actually takes a lot of energy. So if there is nitrogen available in the soil, the crop would rather take it up because it is much easier for it to just take it up from the soil than it is to take it out of the atmosphere. So if you're establishing legumes, inoculation is usually a pretty good option just to make sure that things get off to a speedy start. So if you are planting legumes on a field that have never had the legume that you're planting, inoculation is recommended. Also, if you don't know, if you have grown that plant on that field, but you don't know if inoculation went well, or if you don't know if fixation was very good, inoculation is also recommended there. But also it's normally just a whole lot cheaper than replanting. No one wants to go through the whole process again when you just could get a cheap inoculant and a cheap sticker to make sure things go correctly. So you definitely want to use inoculated seeding, but one thing to do is make sure you use the correct strain of Rhizobia bacteria. And a lot of these strains are already present in a lot of soils, but sometimes they're maybe not present in enough quantities, but also why risk it? And then of course, another option is to buy a pre-inoculated seed. But going back, like I said, different plants have different species of Rhizobia that they like to work with. So alfalfa and sweet clover have some, and then alsike, and then some of the other clovers have a particular species, and on and on and on. So when you're doing inoculate, there are different types. There are powders, there are granulars, there's liquids and frozen concentrates. And if you ever heard the word sticker used, you can, these are used to make the inoculant stick to the seed. So they're commercial stickers that you can buy that are pre-made. I've read about sugar and warm water being used, and then maple syrup and warm water being used as a sticker, which seems a bit like a waste to me, but I guess do what you will. And then when you're establishing, one thing to remember is that moisture is the most important factor. So we definitely want good seed to soil contact. So the best way to do that is through direct seeding or a seed drill. And then if you're broadcasting it, doing a light disking to just make sure there's a little bit of soil on top of those seeds to make sure they don't dry out. Because of course, bacteria without water will dry out and die pretty easily. And so while you're establishing, to make sure the inoculation process is going well and nodules are forming, the easiest thing to do is to just dig up some plants from several parts of the field and take a look. Of course, you don't want to pull these plants up because then, of course, you're going to destroy the roots and not get any nodules anyway. But you want to do this around 3 to 4 weeks after seeding, and you want to look on the inside of the nodule and see if it's pink or red. Don't look on the outside because it may or may not be red. So to give you an example, I believe these are alfalfa roots on the left. You can see those are red on the outside. And then on the right, it's a different crop, but these nodules have been cut open, and you can see they're a pretty dark red color. So pretty confident some strong nodulation or fixation is going on there. And so another thing to remember is that even if the Rhizobia are ineffective, nodules will be produced. But the difference is they will be gray or greenish on the inside. So it's important to pop those open and take a look and see what color they are. But another way to notice if inoculation did not go well is if the plants have a nitrogen deficiency. So if you look near the base of the plant, if the older leaves are yellow, is a pretty clear symptom of nitrogen deficiency. So once everything's established, that's when we start thinking about our nutrient management program. So we'll probably have a different nutrient management strategy for a full legume field and a legume grass mix, especially in a mix because fertilization practices can actually favor one species in that mix over the other. So two of our biggest influences here are nitrogen or phosphorus. So depending on how much you apply, you could end up with more grass or you could end up with more legume. So of course, nitrogen, due to fixation, it's not needed in pure legume stands, but if you're doing a mixture and there is less than 20% legume, we recommend somewhere between 30 to 50 pounds of nitrogen per acre per year, just to make sure that grass has enough. If you're somewhere between 20 and 60%, you can probably cut that down a lot, somewhere in the range of 10 to 25 pounds of nitrogen per acre per year. But then if you're above 60%, there should be enough fixed by that legume to provide to your grass crop. So you should not need to supplement any nitrogen in that situation. Also, excessive nitrogen in the soil can interfere with nitrogen fixation because, as I said earlier, it's much easier for those plants to take up nitrogen than it is to fix it from the atmosphere. So if there is excess nitrogen in the soil, it'll actually lower the percentage of legumes in that stand because grass is much more competitive at taking up nitrogen than most legumes. Another thing to think about is phosphorus. So phosphorus is another thing that can change the proportion of legumes in your mixture. So if phosphorus is not high enough, it will definitely favor the grass because like with nitrogen, it is much more competitive than legumes. So make sure when you're taking your soil tests, you find the correct mix that you have or the correct legume, and it's probably going to be a much higher phosphorus requirement. Legumes also like a high amount of potassium, but they don't really influence stand composition as much as nitrogen and phosphorus. But I will say they do respond very well to fertilization. And of course, potassium is used for stress tolerance, so that usually correlates to greater stand longevity, excuse me, if you apply appropriate amounts of potassium. And then some of our last nutrients to think about in our established stands are sulfur and boron. There's no research that shows that sulfur and boron influence the proportion in the grass legume mix, but like phosphorus and potassium, they're both required in greater amounts for legumes than for grasses, just based on simple nutrient demand. I've already gone over sulfur rates, but boron is actually used to support root nodulation in legumes, but normally you don't need a lot. So I'd recommend if you're below 1 part per million boron in your soil, about 2 to 3 pounds of actual boron per acre would be a good rate to apply. And like nitrate and sulfate, boron is negatively charged when it's in the soil, so it's able to leach below the root zone. So if you're in a coarser soil or you get a lot of moisture, it's definitely possible to lose boron, and that's something you would need to supplement with fertilizer. So I think I'm pretty close to my 30 minutes. So here is my email address and phone number. Of course, if you have any questions or if you don't want to ask your question tonight, you can feel free to reach out to me and ask that way.